All right, Algebra 2, Chapter 2, Section 2, Parent Functions and Transformations. We need to refresh our memory about what a function is. A function is just an equation like y equals mx plus b, but instead of the y, they've changed it out for some other letter like f, and then they put the little x in parentheses next to it. That's called f of x when it does that. You can see an example of a parent function right here. F of x equals 1, f of x equals x, f of x equals the absolute value of x, f of x equals x squared. If you notice down at the bottoms, I've written those out as just a y equals as well, because those are equivalent. So when we talk about the parent function, we're talking about the very first version of that, the most basic, stripped down, no bells and whistles, no adds, subtracts, multiplies, or divides, just the first basic version. There are 4 main families of functions. The constant function, f of x equals 1, is called so because it is constantly a y all of the time. So y equals 1, we go up to 1 and we make a horizontal line at 1 because y is always 1. So that's a constant function. If it's a horizontal line, it's a constant function because y is constantly the same number. Now we need to remind ourselves about domain and range. Domain is what values do we get to use in the x direction? Do we have any limitations? And range is what values in the y direction, up and down, do we get to use. So a constant function goes left and right forever. So the domain is all real numbers. The range, however, it doesn't go up or down. So it is just whatever number that y is supposed to be all the way across. That's what the range is. Now, a constant function is like a linear function because it looks like a flat line, but it doesn't have any slope. A linear function has some slope to it. It's going to be at an angle. Okay? Sometimes it is known as the identity function because y equals x. They have the same identity. They are equal to each other. If you go to x1, you got to go up to y1, x2, y2, so on and so forth. If you look at the arrows, they point to the left and to the right forever, so the domain's all real numbers. We get to use the whole line of x. If you look at the range, it goes up and down forever, so we get to use all real numbers. You might more recognize this as y equals mx plus b, the equation for slope-intercept form of a line. Now that is a little bit different than absolute value. Absolute value, instead of a solid line, it's kind of a reflected line. It's bounced. It goes to a point and stops and starts going back up again. So f of x equals the absolute value of x. I like this one though. It's easy to recognize because absolute value has a v in it, and the shape of the graph is a v. The domain, if you look at the arrows, they go left forever and right forever, so it's all real numbers. But the range is different. Because as you come in from negative infinity and get closer to 0, once you hit 0, 0, it bounces and it goes right back up. So you can't ever go below y is 0. So the range is anything that's y greater than or equal to 0. We can't be negative numbers. Same thing on the quadratic. The QU of quadratic, it's a U-shaped graph. F of x equals x squared. It's exponential. It gets bigger faster. That's different than absolute value. The sides, the arrows of the absolute value actually grow at the same rate the entire way. That's why the line is a straight line. Quadratic gets bigger faster. It goes up by 2, goes up by 4, goes up by 8, goes up by 16, and so forth sometimes. And so it's getting bigger faster, so it's a curved line. It does go left and right forever, so that's all real numbers. But the range stops at 0, doesn't get any lower, so it's y greater than or equal to 0. It's all positive numbers, okay, including 0. You can see the y versions of all those equations down below. Y equals a number, y equals x, y equals the absolute value of x, y equals x squared. Those are the parent functions. You got to learn them, you got to memorize them, because we got to need them. Now, first kind of questions you're going to see, example 1 questions, identifying a function family. Based on the way they give you the equation or what the graph looks like, you have to say what family it belongs to. This one's V-shaped, so it's an absolute value. It also goes on to say compare it to the graph of its parent function. Well, the parent is y equals the absolute value of x. If we were to graph that, we need a little xy chart. I like 5 points, and I like to go right around the origin, 0, 0, especially for a parent, because I know the parents all start around the origin. So I went 2 to the left of the origin and 2 to the right, so -2, -1, 0, 1, and 2. If I plug in -2 for x, the absolute value of -2 is 2. If I plug in -1 for x, the absolute value is 1. 0 gets 0. Absolute value 1 is 1. Absolute value 2 is 2. So that gives me points to graph. -2, 2. -1, 1. 0, 0. 1, 1. 2, 2. Graph the lines. Don't forget the arrows on the end because the lines do go forever. And then how are they different? Well, this one goes up 1 over 1, up 1 over 1, and up 1, back 1, up 1, back 1. This one, the new function, f, the function f of x, goes up 2 over 1, up 2 over 1. So it's actually been stretched vertically. Okay. Not only has it been stretched vertically, but this one's V hits the origin. This one's V hits at 0, 1. It's been moved up 1 place. And if you notice the equation, back here's +1, so this is the move up. And right here is a 2, this is the stretch part. Okay. So we can see differences in the graphs. Those changes in the graphs are called transformations. A transformation is a change in size, shape, position, and or orientation. Sometimes it's one of those, sometimes it's 2 of them, sometimes it's all of them. The first kind of transformation we're going to look at is a translation. That's a left and right shift horizontally, or an up and down shift vertically. It's not making it any bigger or smaller, or spinning it around, or reflecting it. It's just moving it left, right, or up, down. So we're going to graph g of x equals x minus 4 and its parent, then describe the transformation. We got 3 things to do. So g of x is also like saying y equals x minus 4. And if we take off all of the fluffy stuff, we get rid of that minus 4, it's a y equals x, so that's linear. And the best way to graph a linear is slope-intercept form, so our slope is 1, which I'm going to put over 1 since it's a whole number. And our y-intercept is at -4. So if I start at 1, 2, 3, 4, -4, and I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I can even go down and back, keep that same slope. Okay. But I also want to graph the parent. The parent is y equals x. No frills, no chills, no fluffy stuff. Just take everything off but the variables. Y equals x. Okay. Well, my slope here is still 1 because there's a 1 right there technically. My intercept, though, there's nothing back here. The number for nothing is 0. So I start at 0, up 1 over 1, down 1, back 1. Okay. So how's it been changed? Well, there's 4 in between them. So this one's been moved down 4. Okay. You might describe it as being moved right 4, but most people will say it is moved down 4. That's a translation. Left, right, up, or down. Sometimes both. Okay. Sometimes you might go left and up, or you might go right and down. Just depends upon how much movement the original graph has. The second one we're going to look at is reflection. Reflection is a transformation that flips a graph over a line called the line of reflection. When you think of reflection, you probably think of the mirror, right? You see a reflection in a mirror. Your line of reflection is the mirror. There's a line somewhere on this graph, and that's the thing that's bouncing the image and reflecting it. Okay. So let's graph both of these that we have here in example 3. We got p of x equals negative x squared, and the parent of that's going to be y equals just the plain x squared without the negative. So I'm going to make a little xy chart here, and I'm going to go with the same old -2, -1, 0, 1, and 2. You can pick any x values you want, but it doesn't look like it's been moved left or right, so it's going to be around the origin. So I'm just going to use numbers near the origin. Now remember, we're plugging it into the x. So -2 squared becomes 4. 4 times the negative is -4. -1 squared is 1. 1 times the negative is -1. 0 is going to get you 0. 1 squared is 1 times the negative is -1. 2 squared is 4 times the negative is -4. We can graph that guy on there. -2, 4. 1, 1, 0, 0. 2, 4. Remember, it's a parabola, so it's curved. Now we can graph the parent. -2, whoa, that's a bad 2. -2, -1, 0, 1, and 2. -2 squared is 4. -1 squared is 1. 0. 1 squared is 1. 2 squared is 4. So -2, 1, 2, 3, 4. 1, 0, 0, 1. Burp. Burp. So it should look mirrored, okay? And what we have, and I'll draw it a different color, is the x-axis acting as the mirror. So when we describe the change, we would say it's been reflected. And what's the name of the mirror? It's been reflected in the x-axis. That's the mirror that is doing the reflecting, the x-axis. Okay. We're going to pick up there in the next part, talk about the other kinds of transformations.